The next issue is called complementary events. Complementary events are basically opposites of each other, where either one of them or the other must happen. So we sometimes use the word not to identify a complementary event. So not A, or the opposite of A, is abbreviated in math language as A with a bar over top of it. We say that A bar. So that event is also called the complement of A. All right, so if event A is that the 49ers will win their next game, event A bar, not A, is the event that the 49ers win their next game. If A is that a person married by the age of 27, then A bar will mean that they are not married yet by the age of 27. Now, it shouldn't surprise you that these two probabilities add up to 1. If the probabilities that the 49ers will win is 1%, then the probability is the other 20%. So the probability of A bar is 1 minus the probability of A. Pretty basic concept. We just need to see it before we're tested on it. See calculational example 7. Number 7, when drawing a card at random from a poker deck with no jokers in it, let Q be the event that you draw a queen. Question A, what does Q bar mean? How would you say that in plain English? Okay, so based on what we just saw with this bar over the top, that means not. So event Q bar would mean the card is not a queen. Calculate the probability of event Q and the probability of event Q bar. Okay, so by the way, I don't think this class actually tests you on poker decks, but I'll just I'll talk you through a deck. Every deck has 52 cards, and there are 4 queens because there's a queen of hearts, queen of diamonds, queen of spades, queen of clubs. So therefore, the probability of choosing a queen would be your 4 out of 52. Now, to find the probability that your card will not be a queen, at first you might groan and say, oh man, now I have to count all the cards that are not queens. 2 of hearts, 2 of clubs, 2 of spades, 3 of, oh, that's going to take a long time. Well, the good news is you don't really have to do all that counting, because when we use the word not, or the symbol bar, which means the same thing, it means that you can just subtract and consider what's left. So if 4 of the cards in this deck are queens, 52 minus 4 is 48. That means the other 48 cards are all not queens. So you don't have to count them directly. Sometimes it's a lot easier to subtract. So in this case, we would find that the probability of Q bar is the other 48 cards out of the 52. Technically, what we did there is we took the number 1 minus this fraction. But if you work out the fraction arithmetic, you'll find that it's the same thing. All right, our final topic in this section is a very big, very important conceptual issue. And that is the issue of significant results and the rare event rule. All right, stick with me here. This is an important point, and I think the first time the students are exposed to it, it's usually a little bit mind warping. Okay, so let's I'll make sure to take this slowly and carefully. A, if something occurred despite a low probability of its occurrence by chance, it becomes advisable to conclude that it was not by chance. In other words, that something caused it. Let's go ahead and think this through one more time in the abstract. So let's say that there's something that is unlikely to happen by chance, but it does happen. So basically what we're saying here is we can conclude that most likely it didn't happen by chance, but that there was something external that caused it to happen. Okay, so the example that I like to use is that normally when I teach a class, let's say that maybe 10% of the students end up getting an A. All right, so I basically know what that probability is like. What would happen if I administered a midterm and all the students in the class, all 40 of them, all got an A on the midterm? Well, when I pose this question to my students, of course, they always kind of take the student side and they say, well, that just means that your students were really smart that semester. They just studied hard and boy, you had a great class. That's another way of saying that this happened by chance, right? So I just by chance, I had a class of 40 students and they were all A students. That's possible, but it's not likely. I know that it's not likely. I've never seen it happen. Okay, so there's a pretty low probability that that would just happen to occur. So, thinking more like an instructor, my thought would probably be, something fishy is going on here. There's kind of seems to be maybe a little bit of cheating going on. Maybe the answers are getting leaked, or somebody's doing everybody else's work. Okay, so that's kind of what we mean by this rare event rule. Something really unusual happens, and the teacher would be very reasonable to conclude that something is causing that, like cheating. Okay, so again, we need to work with some slightly more objective definitions. We generally use 5% as a default definition of low probability. Think about that spectrum that I showed you a minute ago, in that red zone at the bottom. So 5% will be our default unless a problem specifies otherwise. And here's where we come back to that word significant. Numbers that are unlikely, that unlikely zone is called the significant zone. So numbers that are small and unlikely are significantly small. Numbers that are large and unlikely are significantly large. Let's think through that last sentence a little bit. I think students sometimes have trouble with that one too, because there are concepts of largeness and smallness going on at the same time. But this is where we have to think about those two dimensions on your graph, right? So a significantly large number basically means it's large because it occurs over on the right end of the X number line, but the probability of its occurring is small, so it's basically short on the histogram. Okay, so numbers can be either unlikely to happen because they are smaller than normal or larger than normal, but in either case, the probability of them occurring will be short. Let's take a look at a calculational example 8. Out of all students who take the GRE twice, only 3% improve their scores by more than 10 points. Stella bombed the GRE. She then took an nth degree tutoring GRE prep class. She then took the GRE again and scored 12 points higher. Part A, would you be surprised if Stella made this kind of improvement on her own? Whoops, that part doesn't belong there. Would you be surprised if Stella, on her own, took the GRE and improved her score by 12 points? Yes, we would be surprised because statistically, she only has a 3% chance of doing so. Okay, yes. So what might you conclude? Question B, what might you conclude? Well, let's see. It would be unlikely for Stella to improve her score by more than 10 points by chance, but she did improve her score by more than 10 points. So maybe something caused it. Maybe it was the nth degree tutoring prep class. Okay. All right. So when something unusual happens, we look for a cause. Why? That's really unusual. What would cause that? It probably didn't happen by chance. But Stella took this nth degree class. I'll bet that's probably what the cause and effect relationship was. Okay. C, How would a statistician describe Stella's improvement? Well, her improvement was very unlikely, short, but it was very large, far to the right, 12 points. Wow, significantly large.